Hello everyone, I'm Shweta Bhatt. I'm a student of academic writing, a Swayam Mooc course. I did my PG in MTech Chemical Engineering from Siddhganga Institute of Technology, Tumkur. In this presentation, I'll be discussing about few prerequisites to write electronic configuration of any element. Some of the prerequisites are the definition of an atom, structure, subatomic particles, atomic mass and atomic number, energy levels and subshells, and atomic orbitals. Let us discuss few of these prerequisites in brief. What is an atom? We can say atom is the smallest particle of any element. Atoms are the smallest individual particle which cannot be further divided. If we consider any complex structure and we break it into smaller pieces, we get molecules. And further breaking or dividing molecules leads to individual atoms. Atoms of same elements or different elements combine to form molecules or still bigger structure. Atoms of elements are similar in chemical nature. These are the building blocks of any matter. Now the question arises whether the atoms can be further divided. If you consider the structure of an atom from the previous explanations, we have studied about various models available, and these models, some are accepted, and the most accepted models uh, tell that the atom is made up of subatomic particles, which are protons, positively charged, neutrons, which are neutral, and electrons, which are negatively charged. So the most widely accepted structure of an atom is a center core consisting of protons and neutrons, which are surrounded by electrons. Now the question of whether atomic atoms are further divided, what will happen? Yes, atoms are made up of subatomic particles. But if we try to divide them or if you alter them, that is by changing electrons, adding or by removing electrons, we get atom of different element. So we cannot divide an atom further. If we do so, we'll be getting atom of a different element. But atom consists of subatomic particles, protons, neutrons and electrons, and with the help of these we can tell the nature of any element. Atomic mass. We can represent atomic mass by capital Z. This represents the number of protons present in the nucleus. Atomic number, also called as mass number, is represented by capital A. This is the total number of protons and neutrons of one element of any element, of one atom of any element. So this is the total number of protons and neutrons present. Protons and neutrons together are also called as nucleons. Since the mass of electrons is negligible, the mass of protons and neutrons are widely considered. How to represent any element? This is the representation given for any element. The symbol of the element is written and capital A written in the top left corner and capital Z written in the bottom left corner. A represents the mass number and Z represents the atomic number. So any element's symbol should be written along with the mass number on the top and atomic number in the bottom. These are some of the examples. Na, the symbol of sodium, 11 written at the bottom is the atomic number, 23 at the top is the mass number. Similarly for chlorine, Cl is the symbol, 17 atomic number written at the bottom and 35 is the mass number written at the top. Now energy levels. K, L, M, N are some of the energy levels of any element. If you consider energy levels, they are also called as shells sometimes. K is K shell or K energy level is the shell with the lowest energy level, and this is nearby to the nucleus. If you consider nucleus to be at the center surrounded by electrons, nucleus is surrounded by energy levels, we can say. So K shell is the first energy level that is nearby to the center nucleus, and it has the lowest energy level. Since it is the first and lowest, it is represented by small n 1, which means it is the first or the lowest energy level. It is followed by K shell, the second energy level, with n is equal to 2, M shell with third energy level with n is equal to 3. Next, N shell with n is equal to 4, which is the fourth energy level, which is away from nucleus, far from nucleus, and is having the highest energy level. Next, subshells. These shells are further divided into subshells, and each subshells, we can say number of subshells that is present in a shell is equal to the n value. N value is K shell, if you consider n is equal to 1, or L shell n is equal to 2, that means there are n number of subshells present in any shell. So M shell with n is equal to 3 means there are 3 subshells present in the shell. And these subshells are represented as S, P, D and F. So M shell with n is equal to 3 or 3 subshells, which means n is having S, P and D subshells. Each subshell contains a definite number of orbitals. S subshell is having one s orbital. P subshell is having 3 p orbitals, px, py and bz. D is having 5 d orbitals. F is having 7 f orbitals. Now with the help of this basic information, we can write the electronic configuration by following certain rules or principles. There is F-Bohr principle, Pauli's exclusion principle and Hund's rule. With the help of these rules, which will be discussed in next video, we can write the electronic configuration of any element. Now what is this electronic configuration? It is the arrangement of electrons in the atom of any element in various atomic orbitals. Thank you. This is the open resource prepared for the submission of assignment of Swayam MOC course Academic Writing by Dr. Ajay Simalti. Students of post-graduation and PhD can enroll to this course. This course is very beneficial to know about the journal matrices, author matrices, open educational resources, literature review, review paper writing and thesis writing. It covers almost all aspects which a student of post-graduation doing his or her thesis work or even PhD work can enroll to this course. It also helps as a guide to carry out academic research and to develop various open educational resources. This is the link of the Swayam website. I request all of you to go through the websites and enroll to the course and benefit from this course. Thank you.